Hi, in this video I will demonstrate how to perform one-way analysis of variance, also known as ANOVA. This test is used to test the difference between three or more means. In this problem we have the following information. A researcher wishes to test a claim that there's a difference in the average amount of tips at three popular coffee shops. The data she collects is presented below. Test a claim using alpha equal to 0.05. So we have three different tip amounts per customer for three different coffee shops. So we have to state our claim. Now H0, since we have three different categories, that means we have three means that are set equal to each other for H0. H sub 1 is stating at least one mean is different. That's the claim. Now this is an F test, so we do have to find the critical value. There's two ways of determining the critical value. One is to look it up in the table. The other is to use Excel, and I'll show you both methods. So first we calculate degrees of freedom of the numerator. That's K. K stands for categories. We have three categories. So K minus 1, 3 minus 1 is 2. Then we calculate degrees of freedom of the numerator. That's uppercase N. Uppercase N is just the total amount of data values from all the three categories. And if we count, we got 5 data values per category. 5 times 3 is 15. Minus the number of categories, 3. So that's 12. We can then look up the critical value in table H using 0.05. So we have alpha. Degrees of freedom of the numerator was K minus 1. 3 minus 1 is 2. Degrees of freedom of the denominator was 15 minus 3, which is 12. So we go down to 12, and we can see that that's going to be 3.89. So the critical value is 3.89. Now I'll demonstrate how to find this critical value in Microsoft Excel. So we will be able to generate that value when we compute the test point. So in calculating the test point, my recommendation is to use technology, either a graphing calculator or Microsoft Excel. So let's go ahead and demonstrate this process. We transfer the data to an Excel spreadsheet. We then click on the data ribbon and select data analysis. We choose ANOVA single factor. For the input range, we want to select the entire chart that contains all of our information. I like to group everything in terms of columns. I like the labels and type in the alpha 0.05. The output range is where we want the two tables that will be outputted to be displayed. I like to select a cell that's away from the original data set so it's not overwritten. And then we just press OK. And our key bits of information will be computed. This first table basically lists the summarized data. The second table is where we find our key values. First of all, as I mentioned before, we have the critical value listed there. And let's round it to 2 decimal places. You can see it's 3.89. The other value that's of important to us is our test point. So our test point is 2.22. So that's how we were able to find F is 2.22. That's going to fall short of the critical region since it's to the left of 3.89. This is an F distribution, by the way. So we say do not reject the null hypothesis. There is not enough evidence to support the claim. Thanks for watching the video.